Worledge. I am a consultant in a Santa Clara office of QT Company. Before we jump into the topic, let me just run through some of the practicalities of the webinar. This webinar is being recorded and we'll share it within 2 days of the webinar, so please feel free to share it with your peers, colleagues, friends and family. The webinar is interactive, so please feel free to use the Q&A window to ask questions, and I will reference them at the end of the webinar or between topics or any time I get a moment or notice them. Okay, so our webinar today is on the subject of QObjects, signals and slots and more. We'll be looking at one of the fundamental components of the QT framework. This target audience is mostly people who are fairly new to the QT subject, so it's not going to be super deep, but hopefully you'll get a good overview. First question is, how do you share the recording? It's going to be available on our website eventually, within a couple of days, and you will receive an email to the link to download it. Okay, so we're going to take a look at the QObject and the value-based classes, which are also available in Qt. We'll have a look at how Qt can be used for memory management. We'll have a look at the Qt smart pointers. And we'll take a look at the meta-object system before moving on to signals and slots, which are perhaps the most widely used feature of the QObject, Qt property system, and event handling. Okay. Okay, so the QObject has several important responsibilities in the Qt framework. One of the most useful one is memory management. We can use QObjects for managing the memory of other QObjects, and we do this by creating them in trees. So any QObject will have a parent, which is a QObject, and a child, which is a QObject, or children, which are QObjects as well. When you delete the parent, it will also delete any children objects. So that way you can use it to create large systems like the QWidget, for example, which will then delete any children objects, any child widgets inside that widget, for example. The QObject is also responsible for the event handling, and we have an event system which we'll look at later on. And it also runs or manages the signals and slots, which is an observer pattern available in the Qt framework. We also use the pimple pattern. We pronounce that pimple. It's a private implementation pattern, and that's there to ensure binary compatibility between different versions of the Qt framework, and you will see some of that perhaps while we're looking through the code. This isn't something you really need to worry about at sort of starter level, but it's good to know about it and good to know it's there. If you ever look through the source code, you'll see it's there. A lot of the QObject features are done or achieved using a meta-object system. So a QObject has an associated QMeta-object, which will contain properties and will contain signals and slots and so on and so forth. That's created using a meta-object compiler. So when we run QMake or QBS, the QBuild system, to build our projects, it will, in addition to generating a makefile, will also run a couple of associated tools which will create the meta-object classes. Does that sound clear yet? I guess possibly not, but we'll see soon. In addition to our QObject classes, we also have some value-based classes. So if you have done any object-oriented programming. Okay, since the sound is not clear, let me see if I can do something about that. Is that any better? Okay, hopefully that's better. I've moved the microphone a little. Okay, we also have, in addition to QObject-based classes, so QObject is really the behavioral kind of class. If you're in, is it louder? Good, good. Okay, QObject is essentially a behavioral object, so the QObject is really responsible for a great deal of the behavior of the system, whereas we also offer some value-based classes which are really used for storing data, and we'll take a quick look at those as a comparison. So if we take a look at the QObject and the QString, the QString, of course, is a data class. Can you see the headers here? We can see inside the QString header class, we have a data class right at the top line. Actually says typedef QString data, that's used to store data. Whereas if we look at the QObject to the left, the header class there, we can see there's a whole load of properties and signals and slots and all sorts of things further on down there. But we don't need to worry too much about that right now. We'll just focus on QObject and explaining what all this code means. Okay, so for memory management, of course, first thing we mentioned was memory management. Each QObject may be a parent or a child of another QObject, and that way when you're creating Qt applications, you can create all your QObjects in a tree structure or as a tree. Child objects are allocated on the heap, so you use the new operator if you're familiar with C++, and that will create a new QObject on the heap which can be referenced anywhere. You don't need to keep a track of these pointers because if they're created as a QObject tree, when that parent object is deleted, everything beneath it is deleted as well. So if you look at the top of our slide here, our QLabel has been created with a parent, and when that parent is deleted, so that would be part of a UI somewhere, a widget-based UI somewhere, that will also be deleted underneath. QFile and QApplication and modal dialogues are often allocated on the stack, so these are created without using the new operator. The QApplication, of course, because it's generally created in the main function, so it will be there for the life cycle of the application. QFiles and modal dialogues generally exist only within the scope of a function, so they're not necessarily going to be passed around or used elsewhere. So they would generally be created on the stack. Is everyone familiar with this C++ terminology, by the way? When it makes sense, please. Yeah. If not, then do stop me and ask, and I'll see if I can answer your question. Okay. Another useful feature for memory management in QObjects is the delete later slot. So I think we might have seen that in the code just now. The delete later slot allows you to schedule a QObject for deletion later on, and that way it will be deleted when the event loop is clear and when the QObject's not doing it, when the control returns the event loop. And that's a nice safe way of deleting a QObject, so you can schedule it to be deleted when it's no longer in use. For example, if you're running a Q thread, then you can schedule that Qt thread so when the finished signal is emitted, you can connect it to the slot. And when that exits, it will delete itself automatically. We'll take a look at signals and slots in a minute. But it's safe to call the delete later slot or schedule it to be called multiple times. And we'll see why when we look a bit closer at signals and slots. Okay. For managing your QObject, we offer a couple of useful QPointer classes or smart pointer classes. What these do is they offer, or the QPointer class offers a guarded pointer to a QObject. So rather than just using a regular regular pointer, this is a convenient way of keeping it safe so there's no dangling pointer. Memory-wise, it takes up the same space as a normal pointer. The big difference, of course, is it will set the target or set the object it's pointing to null when that object is deleted. So if you look at the sample code here, you can see that when we delete that object, if the object is not set to null, which we're not setting in the code, then it will cause a crash if you use it or if you try to use it. Otherwise, it will give you no dangling pointer. Take a quick look at how that works. So here's our piece of code we looked at there. So we see we have an example object. The example object itself doesn't really do anything. It's basically just a blank class, subclass of a QObject. all we're doing is we're creating an example object, we're deleting it, and then checking to see if it exists. Can you all see that okay? Okay. So when we run this, of course, what happens is we have no dangling pointer because the pointer is set to 0 when we delete the object. Similar to that, we have a QScoped pointer. What the QScoped pointer does is, to put it in technical terms, it assigns stack-based memory ownership to heap allocations, or in other words, destructs the QObjects, which are, or calls the destructor on the QObject when that pointer, the QScope pointer, falls out of scope. So you would use it in the same way as you would use a Q pointer, but when that comes out of scope, it's deleted automatically. QScoped pointer does not have a copy constructor or an assignment operator, so whereas with a Q pointer you can pass it around like a normal pointer, a QScoped pointer will only stay within the function it's used. You could use this, for example, in exception handling or any kind of function where there's several exit paths in the function. Okay, hopefully that's clear. We also have a couple of pointers used for sharing data objects. So these are the non-QObject classes, or rather the QObject classes on the left-hand side. Shared pointer is used for passing around a strong reference to an object, behaving like a normal pointer. So this is a shared pointer which is designed so that you can share the pointer, and it uses a reference counting mechanism on the inside. When that count drops to 0, it's deleted. Of course, when the shared pointer is passed around, its reference count is incremented. So in terms of reference counting, it's thread safe. And the reason, of course, is the pointer is shared, but the object it's pointed to is actually not shared. There is only one instance of that object. We're just passing the pointer. Because of that, there's no detach, there's no copy on write kind of features for that. That also comes with a weak pointer for tracking. So if we take a look at the pointer or the code sample we've got at the bottom there, we see a QShared pointer is created, or a shared pointer to an object is created. We're connecting that up to a deleter function, which is one of the features the shared pointer has, one of the many features it has, so that when that object is completely falls out of scope, when the shared pointer is deleted, it's deleted automatically using the QObject delete later function. So that way you can create an object and schedule it to be deleted by the event loop when the event loop gets to an end. Hopefully that makes sense. How does it differ from STD shared pointer? It's not greatly different from STD shared pointer. Sorry, someone's asking a question with just the word question. How does it differ from STD shared pointer? It's not that much different. It's more of a Qt specific version of the STD shared pointer. I'd have to check for that, but we can get back to that later on. Okay. For data classes, we also have a shared data pointer. So a shared data pointer is designed to allow us to implicitly share data. This is one of the things our data classes are able to do, is be passed around and they're reference counted internally, and we provide an API where you're able to do that yourself, so you can create your own data classes and you can implicitly share them using the shared data pointer. Again, there's reference counting on this and this, except in this case we're actually calling detach automatically. So the shared data pointer has a copy on write kind of feature. So when you call one of the assignment operators or change operators on a shared data pointer, you can call copy on write, which will create a deep copy and allow you to pass things around and change them without changing the original code or the original object. Additionally, the explicitly shared data pointer does not detach automatically. That's for data which is explicitly being shared, so kind of not the same. Let me just see a couple of questions, but I can't read them particularly clearly because the control panel is not showing me the whole question. Why does Qt not have an API which returns the reference counts? STD shared pointer has used count API. I'm not entirely sure. We don't have the API. It might be possible to do that. Could I give an example of a data class? Okay, a data class, for example, a QString. A QString is reference counted. It contains basically an array of characters. And these characters are passed around or can be passed around. When you change a QString, it copies the whole lot so that you've got 2 copies of the QString, and one of them will change slightly differently, but the original will not have changed. If you've done any Java programming, I think that's a feature of Java as well. Shall we take a look at the shared data demo so we can get an idea of what that's doing? Okay, so in this class we're creating a couple of shared objects, and giving them a shared pointer, and we're passing one of them into the button and another one into the separate thread. So my thread, of course, is basically a Q thread, which contains this shared object which is being passed in. So when we run this, we have a button here, and when we press that button, the shared value is printed. And if we look inside the button, we can see that when we press the button, the clicked signal is sent. That's connected to this random slot, which prints out the current value of the shared object. The shared object itself is held inside this thread, which is basically running around and changing the value of the shared object. So if we press it enough, we might kill the worker at some point. And what we have here is a shared object which is being operated on by the button itself and the thread, so we see the different values of it. Okay, so that's our quick overview of our shared objects. Moving on to our meta object system. Meta object system is used to extend our QObjects with dynamic features in C++. So it's used to extend our QObjects. It's a convenience feature of Qt, not for memory or performance optimization. If anything, it adds a bit more code to the system. So that's therefore, as I said, when you run QMake on your projects, the QMake will run the MOC tool, the meta object compiler tool. What that does is it creates the C++ code for the meta object. So when you run QMake across, or cubes across a project which has QObjects in it, and they have this QObject macro, then it will pick up the macro and it will create the meta object classes, the C++ for the class. What that will do is will provide a mechanism to access the slot functions in the class, so that will give you the slot function access system, one of them. It will also produce various functions to give type, parent type and runtime type information, so you don't need to add RTTI yourself. It will come from running the meta object compiler. It also provides a QObject cast, which is a way of static casting QObjects to parent types if you need them. Meta object system is also going to give us access to the QObject properties system, so the meta object properties system, which we'll take a look at very soon, and will allow you to register enumerations with the meta object system. So basically the Qt runtime will have access to class information about your C++ classes, the parent type, and so on and so forth. Okay, so for example, we have some sample code here. Enumeration has been registered in the meta object system, and you can see that with the QDeclare flags line in the sample code we have here. We also have a couple of properties at the top, and we're registering some signals and some slots. So this is actually from our QQuick window, which is part of the QQuick QML runtime. It's from our source code. You'll see that the Q_signals and Q_slots, we're using the uppercase macros, and we use that quite often in the source code. And the reason for that is because it's more compiler independent than the other keywords. In your own code, you can just write public signals or public slots in lowercase, but this is one way of doing it if you need to. gives you more property or more independence, platform independence. Okay, any questions on that regarding previous topic? Is there? I'll take a look at that. So is there anything resembling a unique pointer? The Q pointer is just a pointer. It doesn't quite do STD unique pointer. Sorry. Okay, so signals and slots. Of course, a signal is a way to inform an observer or to let an observer know that something has happened. So if you've done a lot of object-oriented programming and you've used the observer pattern, the signal is our way of saying this is the function that you'll be listening for. This is something which will happen. So as we mentioned in the earlier slides, the meta-object compiler will create a whole load of functions for you. So when you create a signal in a QObject, you don't actually need to implement the body of that signal at all. You just need to create it in the header file. And that's a useful feature. The reason for that is because the signal is basically handling the observer pattern. So when you register a slot with a signal, it's stored in this part in the C++. To emit that signal, to send that signal, we generally put the keyword emit in front of it. This actually doesn't do anything. So if we take a look at a little bit of code here, we can have perhaps a clearer idea of that. Okay, so this is our QWidget header file. If we scroll through here, we can see there's a whole load of QObject Q properties in here, and we'll find there's a couple of slots. So we see, I'm actually looking for signals, not slots. What am I doing? There we have the signals. So we see there's a couple of signals here. These signals themselves, if we look at them in the C++ body of the code, we'll see that these don't actually exist there at all. So if we switch to the widget C++ and we look for window icon text change, we'll see that the window icon text change, this is a signal which we saw here. It's deprecated, but still there. But this is actually present only in the window title changed. This is actually only present in two places in the C++, and there's no implementation of the body. That's because the implementation is taken care of by the meta-object compiler. And we see the emit keyword here. The emit keyword is used to show really that it's a signal that's being sent in the C++, so it's a little bit easier to read. If we drill down, so what I'm doing here, if you're using Windows or Linux, you press Control. On a Mac, you press Command and mouse over. You can drill down into the code. If we look at the actual emit, we can see that the emit keyword itself doesn't actually do anything. It's just a blank keyword because we're really just calling a signal elsewhere in the code. Or we're really just calling it a method of the class which has been defined elsewhere in the code. Okay, similar to signal, a slot is the function which it's connected to. So the signal is connected to a slot. Generally, signals can be connected to signals as well, but generally it's connected to what's called a slot. A slot, of course, is a normal member function which has been implemented by the developer because this contains the behavior or the code which will be executed as a response to a signal being sent. So if we look at our code here, we've got a new slot which basically just emits another signal or checks to see if something's been changed and emits the signal. Okay. So to receive that signal, to receive a signal in the slot or for a signal to be sent to another signal, you need to first connect those, and we use the QObject connect method. This is another method which every QObject will have. The QObject connect, we pass in the sender object and we pass in a reference to the signal which we're sending from there. We pass in an observer object and we pass in the method. Additionally, we've got an optional connection type which can be sent. In most cases, this will return a meta-object connection class which you can use to check if the connection is successful. In most cases, it's successful. You don't generally use that. if you're using a lambda expression, which we'll look at in a minute, then you can also use that to check or to disconnect the lambda connection later on. Of course, when a Q object is deleted, its connections are all removed anyway. So in many cases, you don't need to store that, because when the object is deleted, it will be disconnected from everything as well. Okay. QObject connect static method. It is, or it can be accessed statically. So that's QObject connect can be used statically as well. Can we see that here? Okay, perhaps it wasn't such a sensible idea to look it up in the code, because it's taking its time to come up, but you see it's here, and it's a static method, so it's available statically from without a QObject, or it can be just called as a member function of a QObject as well. So yeah, both. Okay. So signals and slots signatures need to match. Of course, if you're calling a method directly, of course the signals need to match, and it's the same with signals and slots. The signatures need to match. There's two ways of creating connections, or overall there's two ways of creating connections. You can use them using strings. In this case, if we look at the left-hand side in the blue area, you can use a string to create a signal. Use the signal macro, which will turn that code into a string. And you can connect that to another string using the slot macro, or another signal macro if it's a signal. This is the old Qt 4.8 and previous way of connecting up signals and slots. It's useful because you don't need to really worry so much about the parameters and the signals. So if you've got an overridden class, it's easier to connect that way. But it's actually slower as well for execution, because it uses a string lookup inside the C++ class. So in this case, it will not run so quickly because it's looking up a couple of strings inside. There's a quicker way of doing it in the new case, in the new Qt 5 API. If you look on the left-hand side, we can also use function pointers. So you can connect directly to a function pointer instead. Of course, with the older version, this doesn't give you compile time error checking, but with the newer version, if you're connecting directly to functions, you do get compile time checking. You also get implicit type conversions because it's a function pointer and not a string. It's more complex if you've got a lot of overloaded signals and overloaded slots, as we'll see, but the API is a bit easy to use, and it executes quicker. Okay, so we've got a question about connection type. Let's take a look at that now. So for connection variants, actually I say take a look at that now, we'll take a look at that on the next slide. Connection variants, there's no special syntax for slots, as we mentioned. QObject is not needed for slots. If you're running using the functor type, you don't actually need to specify the QObject macro, because a slot is essentially just a function. Using a function pointer we have here, so if we look at the code sample we've got here, when we connect, the slider of course is the slider pointer to a Q slider. When the value is changed, if we have a spin box, then it will just set the value, so you can use that function pointer there. You can also, if you've got overloaded slots, then you would need to define a pointer to that and create or add the explicitly defined which signal parameters you're using. So that's a bit more complex. Is everyone okay with that? Additionally, you can connect to non-member functions. So we have a print value. We can connect to that, to a non-member function. If we look at the value, the static void print value function here, we can see we're just connecting to a static non-member function, which is just there. We can do that with the funct pointers as well, which we couldn't do with the earlier version. Additionally, if you like, you can also connect using lambda functions. Of course, if you connect to a lambda function, which is basically an inline C++ function, you're not going to have any way to come back to that later on, because you won't have, it's not connected to an object, it's just a function. So as we saw earlier, the connection call returns a meta object call type, a meta object connection type, but you can use that to disconnect as well. Okay, let's have a look at that in action. So this is a fairly simple code sample we basically have a slider which has been connected to the QDebug stream. So when the slider value changes, it will print the QDebug and will set the value of the spinner directly. It's not connected to an object, it's just connected directly to this lambda function here. So if we run that, you'll see changing the value will go through the lambda function, it will print the QDebug and set the value on the spinner. Okay. So I've got a couple of questions coming up which I need to take a look. Static cast is more applicable than C-star, right? Yeah, for QObjects, you probably want to use the QObject cast. It's a little bit safer. Okay. Where's the no receiver object for the print value example? Good question. What we're doing with the print value example here, we're actually connecting the value change signal directly to a non-member function. So in the print value here, the print value doesn't have a receiver object. We're just connecting directly to a non-member function, which we can do using the function pointers variant. Okay, time is getting on, so need to crack on a bit. Okay, so connection types. When you connect a signal to a slot, the default type is the Qt auto connection, and this is useful because it allows Qt, or Qt will work out what type of connection is best for the connection. Auto connection will choose a direct connection in most cases if it's just in the same thread. So a direct connection is, of course, an immediate slot function call. So when the slot is looked up from the lookup table in the meta object, it's just called directly. Of course, you can't do that if you're running across threads, if you're sending a signal to a slot in another thread. So what we'd use in that case is the Qt queued connection, and that will send it to the event loop, which will put it to the correct thread and send it to where it needs to go. So an auto connection will generally choose the right case. In some cases you might want a direct connection specifically, or you might want a queued connection if you've got a lot of work to do in the slot and you don't want a slot function call. You can use a queued connection and send the event into another event loop, for example. We have a couple of other connection features as well. Every time you create a connection, it's added to an observer list, and if you create a connection multiple times, you'll have 2 instances of that connection, and the slot will be called twice. You can actually, or the unique connection, you can use the or feature, or in the unique connection value, Qt unique connection, to make sure that the connection is unique every time. Okay. Performance of auto connection versus direct connection. Good question. So direct connection, of course, is calling a function directly. An auto connection will at runtime select between the direct connection or the queued connection. So really the performance difference is the direct connection versus the queued connection. Of course, for actually calling that connection, the queued connection is going to be slower because it's going through the event loop, whereas the direct connection will be a lot faster. So the direct connection will be faster just for the basic return, and if you needed to specifically use a queued connection, then say if it's going across threads, or if you had a reason to use a queued connection, then it would go that way. But of course, actually calling the function itself is not as fast. Okay, does that make sense? Okay, when it comes to disconnecting your signals, the API is essentially the same as you do with connection. You can just disconnect everything. So you disconnect everything from one sender object. You can disconnect everything from a specific signal, and you can also disconnect a specific receiver from a specific sender object. Finally, you can call disconnect for a specific signal and a specific slot. Of course, if you don't have a receiver, or if you don't have a even an object or a function to disconnect from, say you've used a lambda, then you would need to actually specify the connection itself. So you'd need to store the connection object itself. Okay. Let's have a look at the QProperty system then. I think we saw in the QObjects class just now there was a lot of QProperties. Oh no, wrong one. Sorry, we skipped a bit there. Let me go back to where we were. QProperty system. Okay, so if we look inside our QWidget here, we see that there's a lot of QProperties up at the top of the QWidget. They're all here. And what does the QProperty macro mean? What are we offering here? A QProperty is a way of adding properties to a particular QObject, which can be called later on just by using the member or just accessed as a property of an object. So it's the basic way of adding properties to an object. In the header file, we do this with the QProperty macro, which specifies the type and the name of that object, or the name that the object or the property will have from the class. The read and the write macro, if we see at the top here, the read and the write macro are really referring to the functions which is set. So the property called title, the property system knows that when that's accessed, then it's reading it using the title function method, and when it's writing to it, it's using the set title, and it will carry that internally for you. There's also a shorthand for it, so you can also use the member macro, so you can just define a property as a member property and it will add the read and write for you automatically. You can access this in a couple of ways. If you know it's a QObject, you can access it using the QObject property function. If we know the name of it, then we can just, if we know it's a QObject, we can access it and get it and set it using the property and set property. Additionally, if you are calling set property on an object which doesn't exist, then it will create it automatically, and that's another way a second way of adding properties to an object or to a QObject. And there's a few other attributes. So notify is a way of specifying a signal which will be emitted when a property changes. Scriptable makes it accessible to our scripting system. Designable adds it to the Qt designer. Member, we see at the top we have a member which automatically adds the read and write. Final marks it as one which can't be changed. So if we look in here, we have QProperty, so the position can be, for example, the read is a pos. If we look through there, we'll find a function which returns the Q point. The write will, if we move it, then we call that function automatically to move it around. So some sample code for that. Okay, we're running out of time a bit, so we won't get too deep into this. This sample code basically provides a property. We can see that the text, the read text, is the function used to read it, and that basically returns the m_text string, which is a private variable and not accessible. It kind of turns that into a non-private variable. We're adding it to the set text, or we can use the set property to change the text because it's given the name myText. Okay. Additionally, we can register enumeration so that they're also available to the property system, to the meta object system. So if you need to access enumerations, they're done by creating a QDeclare flags and looking at them that way. Okay. So any questions on QObjects, basics of QObjects so far? We have three kinds of classes in Qt. We have a QObject class, which is, or the behavioral class. We have value-based classes, which can use implicit sharing. They're used for storing data. QObject provides memory management, meta object system, and event handling. And the meta object system is an extension to C++. Okay, question is, when is it useful to use the property system? It's very useful. The property system comes in handy if you're animating features. So for Q animations, say for example in the graphics view or in the Qt quick frame type framework, the property system is very useful for that because you can just access values directly without knowing the type. How can one know what type the class is? Okay, you can tell what type of class is by accessing it through the type function. Actually, there's a demo for that. I'll show you that. Okay. It's the difference in normal C++ attributes. The Q property allows you to access the attributes of a class dynamically through the meta object system. So if you don't know the class type, you can query it. Let's take a look at this demo we had for properties. Look, wrong way. Let's take a deeper look at properties then. We'll get into some questions about them. So this is a fairly simple demo we've got here. What we have here is a main method. We're creating a Q core application, setting an object name. So someone was asking about setting the object name. You set it that way. Set the organization name, application name, and the domain name, organization to name. So of course we're qt.io. We can set a new property. So in the line here, we're setting a new property with a value of 42. And what we're going to do is we're going to access that property using the simple get property name type. And we're going to access all of those properties using the Q meta object. So to get the class type or the class name, we're going to use the meta object from the Q object. And we do that by every Q object has a function to return the meta object. So we call object meta object. That gives us the Q meta object. We can use the meta object to access the class name, or if you wanted to access the class type, it should be possible in there as well, class info. So yeah, you'll be able to get all the class info, including the type, that way. So what this will do is we'll access the properties from the meta object, because of course the QObject stores these all in the meta object, and we'll iterate through them and list them all. Okay, so we'll just run that so you can take a look. So can you see that? Okay, what we've done is we've accessed the object name and the object type. Should be there somewhere as well, and we can see what's happening that way. Yeah. Okay. How to know what kind is a particular class. Hang on a second. So do you want to know what type of class an object is? Okay. So that's the Q property system. That's the meta object of the classes and so on and so forth. Okay. Move on to, we've got 15 minutes left, so we'll just quickly look at events. Q events also are a feature which is managed by the QObject class. Got a lot of questions here. I'm getting slightly overwhelmed. Okay, so there are several types of events available in Qt. We have spontaneous events. So from the system, we'd have an asynchronous mouse or a key press event, and that's processed by the event loop. We can also post events. and we can send events, so we can use the Q application to post events back to a system if we need to. Events versus signals then. Events are not quite the same as signals. When a user presses a button in a UI, this of course creates a Q event, which is passed to the event handler and eventually comes to the Q push button object. The Q push button will emit a signal to say it's been called, and that signal will go on to the various other objects. Okay. So QObjects event handling in Qt, events themselves are object and they're passed on to the QObject event handling functions. The base class of all of these is a Q event, and this has subclasses like mouse event and key event, timer event, etc. Each QObject itself has a event handling function, so the QObject event function is called with the event, and this will then pass it on to, depending on what event type it is, to the corresponding event handler, the virtual event handler. All of the event handlers are virtual and can be overridden if necessary, and they should return true if you're handling the event and false otherwise. Okay. The Qt provides an easy way to handle most system events. In Qt C++, your QObject or QWidget subclass can respond to key press events, timer events, mouse press, and so on and so forth, the resize and move events, by just re-implementing the resize event or overriding the resize or move event or the mouse press event, so the relevant event handler can just be re-implemented. Each virtual handler function can then replace the base class implementation completely, or it can extend it by returning whatever it needs to. So if we look at this sample code here, we're responding to a mouse button. If it's a left button, we handle it ourselves. If not, we pass it back to the superclass. Okay. If you need to create a custom event, you can also do that yourself. You can inherit from the Q event. So you subclass the Q event class, give it a event code between 1000 and 65535. Qt won't handle these themselves, but it will recognize as a custom event has been added. So you can then just re-implement the custom event function, or the QObject event function if you want to check it at a higher level, and that will allow you to create and respond to your own events in your QObjects. Additionally, you can send and post these back to the event loop. So the easy way to do that, if you need to know where it's going to, so an easy way to get hold of the current active window or focused widget is using the Q application static function to get hold of what's currently focused. So if you have a UI event which you want to pass to the currently focused widget, you can do that. And that will go straight into the event loop. We're not going to look too deeply at Q event loops because I'm kind of running out of time, but basically a Q event loop is run inside a Q application. They also run inside dialogues and Q menus, and they'll run when the exec call is called. So if you look inside the main function here, you'll see we have a Q core application, and actually it's not. This is perhaps not the best one. We see the app.exec function here is starting up the event loop when we call that exec function. Event loops are modal, so only one will be running, or one will appear at a time. So if you, for example, open a Q dialog and it starts its exec function, it will stop the others. Event loops are also recursive. Okay. You can also add your event filters as well, so we have a means to do that too. Okay. Okay, so you can add event filters. This is a fairly simple way of adding an event filter onto a QObject. So if you have access to a QObject and you need to filter events happening to it, you can also do that, and that's generally useful as well. final thing you need to know about event handling is they're not handled particularly well for objects with no thread affinity. In fact, they're not handled at all. If an object is not belonging to a thread, then the event loop is not running and events such as signals and slots won't happen there at all. Okay, I'm going to answer some questions now. We're kind of running a bit out of time. Can we get demo project files at end of course? Yeah, we can certainly send you the the demo project files. They're not, I think they're not going to be distributed normally, but if you got my email address there, then just contact me and I can send you the demo events, demo classes. Okay, is there anything we wanted to look at a bit closer, or are we happy with QObjects so far? Okay. So tool to statically analyze signals and slot connections in a large system, where we're bringing that into QCreator. There's no tool in a large system to check what's connected where. I'm not sure we're planning on doing that either. Debug techniques for missing signals. Not quite sure what you mean by that. Debug techniques for missing signals. Okay. If there's no further questions, then, if I hook up a slot to a specific signal and don't get it. Yeah, if you connect a slot to a signal and it doesn't come, then you should get an error message. It should actually work. I've never heard of it not working. Okay. Is it wrong to instantiate QObjects or QObject subclasses on the stack? What conditions must be met to use a custom QObject subclass on the stack, like QFile dialog? It's not wrong to instantiate QObjects on the stack. What conditions you'd need to meet? If you're sure that the QObject is not going to be used outside of the stack and you don't need to pass it on, then it's absolutely fine. So if you have a method which will open up a dialog, say QFile dialog, and it's just going to be used in that method, then yeah, you can absolutely create it on the stack. It's only really if you need it to be more persistent than a single method. Okay. How can I get event handling other than main window class? Okay, event handling is a feature of QObjects. So if you have a QWidget and you need to subclass that, you can do so. So if we take a look at the event filter sample here, we can see the kind of thing we're doing here. In this case, we're using an event filter to handle the events, but it's kind of the same approach if you were subclassing a QWidget or a QObject. If we look at our QObject here, it's basically it's a subclass of a regular QObject. You can also override the regular event method as well if you needed to. So you could also use that approach and any of the other subclasses. So in a QWidget, you would have a whole lot more like mouse event, key event, etc. And that would allow you to override, or that would give you the event handling in your class. In this case, the Q event is just responding to, or the event filter is just responding to the mouse event. So as the mouse moves over the checkbox, it prints up a message. This is one way of doing it, and there's other ways of doing that you can use by just simply subclassing things. Can double deletion occur on object owned by parent object and Q pointer? Good question. I don't think so. I think the Q pointer will check, or the Q pointer will know when it's deleted, so it's not going to delete it twice. So yeah, I'd have to check, but I'm fairly certain that no, it won't happen. Okay. Okay, do we have any more questions, or are we good to go for now? Okay, so thank you very much for coming. You should get this recording in a couple of days. You can share it and download it if you need to. If you have any further question, or if you want to get hold of the demo code or clarify anything from this, because I think when I'm doing this kind of speech, it can get kind of confused. So please feel free to email me for clarifications. Thank you very much for coming, and I hope this has been useful for you.